All right, this is homework 8.4. We're transforming logarithmic parent functions, and I'm going to do only two of these, I think. The first is number 3. These are the ones that I feel like people have struggled with in the past years. This says a logarithm with a base of 2. So we're going to write y equals log base 2. That is reflected over the x-axis. If it's reflected over the x-axis, it's going to have a negative in front of the log. Shifted left by 7. So it's going to be x plus 7 inside of the log. This is a shift left by 7. And down 5, that's outside of the log. So the first thing we want to do when we're graphing this is graph where the new asymptote is going to be. But I think it really helps if you're not great at this to graph the parent function. I'm going to graph the parent function in red. The log base 2 parent function has an asymptote at x equals 0. It has, as all of our parent functions have, it has a point at 1, 0. And then log base 2 of 2 is 1. Log base 2 of 4 is 2. When x is 8, log base 2 of 8 is 3. And it follows this asymptote here. Log base 2 of 1/2 is -1. Log base 2 of 1/4 is -2. And it has this asymptote. So this is what the parent function looks like. So let's shift this. Let's draw the new asymptote first. The asymptote is going to be shifted 7 to the left and down by 5. It's a vertical line, so shifting it 7 to the left moves it. Shifting 7 to the left moves it, but shifting down by 5, it's still an infinite line, and so that won't have any effect on it. So the new asymptote is going to be left by 7 at x equals -7. I guess I should be doing this in blue because the parent function was in red. And so let's fill in our asymptote, x equals -7. I like to take 1, 0, and it's important the order we do this in. So first this point gets shifted left by 7, and then it gets reflected across the x-axis, but because it's already at 0, negative of 0 is still 0, and then down by 5. So it gets shifted down by 1, 2, 3, 4, 5. And this is where this point ended up. This point at 1, 0 moved to here. This point at 2, 1 shifts left by 7, gets reflected over the x-axis, so it gets multiplied by -1. Now it's down here below the x-axis instead of above, and then gets shifted down by 5. We could keep doing this with points. This point here gets shifted left by 7. It gets reflected across the x-axis, so instead of being at +2, it goes down to -2. That's what multiplying by -1 does. And then it gets shifted down by 5. So, oops, that point was supposed to be there. So down by 1, 2, 3, 4, 5. We could similarly do this with points along the asymptote, or we could just follow the asymptote because we know what it's going to look like. This is our graph. Notice, instead of being increasing, the new graph is decreasing. That's because it got multiplied by -1. It got shifted to the left by 7. You can really tell that in the asymptote, and it got shifted down by 5. So this is a weird looking graph. The domain for this new graph is x is anything greater than -7, because that's where all the x values will be. And it keeps going up and keeps going down, so the range is all real numbers. Obviously, you could write that in a couple different ways. It doesn't matter to me how you write it. We'll do one more. On the back, this says a logarithm with a base of 10. So we're going to write y equals, and this time we won't write log base 10 because we just write log, and it automatically will have a base of 10. Log base 10 that gets reflected across the y-axis, shifted to the right by 4 and up by 1. So this time that reflecting across the y-axis is being reflected horizontally, and that transformation is when we put a negative inside of the log in front of x. Remember that we have to have that negative factored out or it won't shift the right way, so it's log of negative x minus 4 plus 1. This is 4 to the right, up by 1, and that negative is inside of the log to make it reflect across the y-axis. So let's look at what happens. Our parent function is log base 10, and it has an asymptote at x equals 0. Log base 10 of 1 is 0. Log base 10 of 10 is 1, so it grows very slowly. And it follows the asymptote, so it looks like this. This is our parent function. And we're going to do these transformations. The first thing that happens is it gets, we want it to reflect, so it's going to reflect. So instead of being 1, 0, this will be at negative 1, 0. And it also got shifted to the right by 4. 1, 2, 3, 4. I guess I should be doing this in blue. So it got reflected, shifted to the right by 4. 1, 2, 3, 4. And shifted up by 1. So that is this point moved to here. This other point got reflected, so instead of being at 10, 0, 10, 1, it's at negative 10, 1. Shifted to the right by 4, 1, 2, 3, 4, and shifted up by 1. I guess I should also, I should have started by moving my asymptote. The asymptote got shifted to the right by 4, so the new asymptote is at x equals 4. And it's much easier to see now that we've done that what's happening is it's going up. It just got reflected horizontally. So instead of the log going to the right, the log is going to the left, increasing as we go to the left. The asymptote will be at x equals 4. The domain is now x is less than 4 because all the x values are to the left of 4, and the range is still all real numbers. I hope that helps. That's all we're going to do for this one.